this is section 10.3, hypothesis testing for a population mean. If you remember back from chapter 8, which was about sampling distributions, we learned that the distribution of x bar, the sample mean, is approximately normal with a mean of mu and a standard deviation of sigma divided by the square root of n, provided that the population from which the sample is drawn is normally distributed, or if the sample size is sufficiently large. The problem is it's unreasonable to expect to know sigma without knowing the mean. So we actually use the sample standard deviation S to approximate sigma. This results in what is called a t-distribution. Remember, we talked about those also in chapter 9. And the t-distribution is used to perform hypothesis testing on a population mean mu. Testing hypotheses about a mean follows the exact same logic as testing the hypothesis about a population proportion. The only difference is that we use the t-distribution rather than a regular normal distribution. So how does that change things? Only a little. We still have 3 requirements. The first requirement is that the sample is obtained using a simple random sample. Or from a randomized experiment. The second requirement is that the sample has no outliers, and the population from which we drew the sample has to be normally distributed, or the sample size n is large. And by large, remember, we mean that it has to be greater than or equal to 30 individuals. So to check for normality, we would normally construct a histogram and make sure that it looks approximately normal. So minor departures from normality will not adversely affect the results of our hypothesis test. And to check for outliers, we would construct a box plot, and that would be with the fences. So we know if we have outliers or not. And our third requirement is that the sampled values are independent. And that means that the sample size is less than 5% of the population. And if you remember in notation, we wrote n is less than 0.05 capital N, because lowercase n is the sample size and capital N is the population size. The steps are virtually the same. We start by determining the null and alternative hypotheses. And just as with the proportions, those can be structured in 3 ways. H naught will be mu equals, and we use mu naught. So mu naught is the hypothesized value. Of the mean. And we mean the population mean here. And then H1 will be the mean is not equal to the hypothesized value. Again, if we have to do that on a normal curve, we have our test statistic, and we need both tails for the two-tailed test. Left-tailed, we have H naught. Mu is equal to mu naught. And H1, since it's a left-tailed test, will be mu is less than mu naught. So left-tailed test means we have our test statistic and we go to the left. Right-tailed is the null hypothesis is mu equals mu naught, and the alternative hypothesis is greater than. And so that one looks like test statistic and we need the probability to the right. So the second step is we select our level of significance, alpha. And again, how small we make it depends on the seriousness of making a type 1 error. And again, the type 1 error, you can find information about that in section 10.1. Then using technology, we compute the test statistic. Which is T0 or T sub 0, T naught. And again, the p-value. So in the calculator, we go to the same menu as in section 10.2. So it's stat and over to the test menu. And then we want to select option 2, the t-test. Then we highlight stats and press enter to select it. Or if we need data, we can highlight it to select it. Remember, stats and data work the same way in hypothesis testing about a mean as they do in confidence intervals for a mean. Then we identify the population mean, enter the summary statistics, which is X bar. Remember, X bar is the sample mean. SX is the sample standard deviation. And N is our sample size. And then you pick the type of test. Remember, two-tailed is not equal, left-tailed is less than, and right-tailed is greater than. And it will always say mu0 right after the symbol. And then you highlight calculate and you press enter. There are also instructions here for doing this in StatCrunch. If you just follow this path, go to Stat, T-Stats, one sample with summary, give it the sample mean, the sample standard deviation, and the sample size, and then tell it to do a hypothesis test for mu. Put the hypothesized mean in the box where mu0 is labeled here, and then put the correct symbol between mu and mu0 depending on what type of test you have. And remember, again, it's not equal, less than, or greater than. And then hit compute. For step 4, we compare the p-value to alpha. Remember, if the p-value is less than alpha, we reject H0. And if the p-value is greater than or equal to alpha, we do not reject the null hypothesis. That is exactly the same as hypothesis testing for a proportion. Then we state the conclusion regarding the alternative hypothesis. So we turn the parameter mu back into the context of the problem, and we also have to state the significance level. That concludes the basic setting up video. We will do examples in the next video.